This simulation example is related to cylindrical capacitor. On our website there is a page explaining details of the problem setup. We should find capacitor parameters and let's start the simulation. We should define the problem name. Specify the problem type. In our case it is AC conduction. Choose the problem model class. In our case it is Axisymmetric. Set up frequency. Select length units, in our case millimeters. Specify coordinate system, precision. Now we see the model editor window. Let's start defining the model geometry. We should switch to insert mode and start adding vertices which describe the geometrical model. In our case the model represents the tube, so we should define upper half of the tube cross section, considering the tube is positioned horizontally. Axis of rotation is x-axis. Now we switch the zoom level and see all the vertices in the model window. We connect nodes by straight edges. And surround the structure by half arc. And then by other half arc. At larger radius to specify the external boundary of the problem. As you remember, this problem is axisymmetrical, so we define just half of the cross section. And then we close the geometry by straight line along the axis of rotation. Now we need to assign labels to all objects which have physical properties. This is air, and this block is a wall of the ceramic tube. We assign label ceramic. Now we select edges. For multiple select we should keep Ctrl key on the keyboard pressed, and then by clicking right mouse button we activate context menu and may choose properties and apply label value. The same for other electrode. Deselected, click right mouse button, select properties and type in text label name. For this edge, we specify name axis of rotation. This is the external boundary of our problem. Now we start applying physical properties for each label. Air has just electric permittivity, ceramic has permittivity and some small conductivity, at the axis of rotation we may leave it as it is, or specifically put normal current density is 0. And for electrodes we choose predefined voltages. First order boundary conditions. And for boundary we don't set any boundary condition in this case. It means it is a default boundary condition. But boundary is far, it doesn't affect the field inside our model, inside our capacitor. Problem is meshed. Solved. Now we could analyze the results. Right mouse button displays context menu, and then we could select adjusting the presentation parameters. To calculate the integrals, we need to specify contour first. We select one of electrodes as a contour. Then by clicking on integral button, we activate calculator and may see the integral quantities related to this edge, to this integration contour. Now we select the block and surrounding contour and may calculate integrals related to this closed contour. We see the active and reactive power, and this let us calculate the dissipation factor. More examples are available on our website, and we would be glad to see you